Our solar system is an elegant dance of planets, moons, and asteroids all swirling around a single star, our Sun. This giant ball of burning gas is the ultimate source of energy for life on Earth. It bathes us in light and warmth. The Sun's gravity keeps us in a stable orbit, allowing our planet to thrive. We owe our very existence to this solitary star. But what if our Sun wasn't alone? What if our pale blue dot orbited not one but two suns? The universe is vast and filled with wonders, and binary star systems, where two stars are locked in a gravitational dance, are surprisingly common. In fact, they're more common than single-star systems like ours. Imagine a sky illuminated by two suns, casting intricate shadows and painting the heavens with vibrant colors. Could life as we know it exist in such an environment? Let's explore this intriguing possibility. If Earth orbited two suns, our planet's celestial waltz would be far more intricate. The gravitational forces exerted by two stars would create a dynamic and ever-changing environment. Instead of a simple elliptical orbit around a single star, Earth would be caught in a complex gravitational dance with two stellar partners. This dance would be influenced by the relative positions and movements of the stars, creating a unique orbital path for our planet. The exact nature of this dance would depend on the masses of the stars and the distances between them and Earth. Larger stars would exert stronger gravitational pulls, while the distance between the stars would determine the shape and stability of Earth's orbit. One possibility is a figure-8 orbit, where Earth swings around one star then loops around the other, and repeats the pattern endlessly. This type of orbit would create a fascinating and ever-changing sky, with two suns rising and setting at different times. Another possibility is a P-type orbit, where Earth circles both stars in a wide orbit, treating the binary pair as a single gravitational center. In this scenario, the two stars would appear close together in the sky, almost as if they were a single, larger sun. The combined gravitational pull would create a stable yet expansive orbit for Earth. The seasons on Earth would be affected by the varying distances between the planet and the two stars. Summers could be hotter and winters colder, depending on the relative positions of the stars. The light patterns on Earth would also change, with periods of intense brightness when both stars are visible, and dimmer periods when one star is obscured by the other. This would create a unique and dynamic environment for life on our planet. Life on Earth would have to adapt to these changes, potentially leading to diverse and resilient ecosystems. The presence of two suns could provide more energy for photosynthesis, supporting a rich and varied biosphere. Advanced civilizations might develop unique technologies to harness the energy of two stars, leading to innovations in energy production and space exploration. The challenges and opportunities presented by a binary star system would shape the evolution of life and technology on Earth. In conclusion, if Earth were in a binary star system, it would be a world of complexity and wonder, with unique challenges and opportunities for life and civilization. The intricate dance of two suns would create a dynamic and ever-changing environment, shaping the destiny of our planet in ways we can only imagine. Two suns would undoubtedly bathe Earth in significantly more energy than we receive from our lone star. But would that mean double the heat? Not necessarily. The actual impact on Earth's climate would depend on the type of stars, their distance from Earth, and the planet's orbit. If the stars were small and cool, such as red dwarfs, even their combined energy might not be enough to sustain liquid water on Earth's surface. Conversely, if the stars were massive and hot, like blue giants, Earth might be cooked to a crisp. Section 5. Life under two suns, a day in the life. Imagine waking up to a sky illuminated by two suns. The morning light would be unlike anything we experience on Earth today. Instead of a single source of light, two suns would cast overlapping shadows and create a unique interplay of light and color. The warmth and brightness would be more intense, and the day would start with a surreal, almost otherworldly glow. The rising of each sun would mark a distinct phase of the day, creating a complex pattern of dawn, dusk, and twilight. Imagine the first sun rising, bringing the initial light of day, followed by the second sun, intensifying the brightness and extending the morning. As the day progresses, the first sun would set, leading to a unique period of partial twilight before the second sun follows, creating a prolonged and dramatic sunset. The length of day and night would vary dramatically depending on Earth's position in its orbit. In some parts of the year, the days might be incredibly long, with both suns in the sky for extended periods. In other times, nights could be longer, with only brief periods of daylight. This variability would create a dynamic and ever-changing environment, challenging both humans and nature to adapt continuously. Plants on a binary Earth would need to adapt to these unusual light cycles. The dual sunlight would affect photosynthesis, the process by which plants convert light into energy. Some plants might evolve to photosynthesize more efficiently, taking advantage of the increased light. Others might develop different pigments to absorb light from the different types of stars, ensuring they can thrive in this unique environment. They might evolve to photosynthesize more efficiently, optimizing their energy production to cope with the varying light intensities. This could lead to a greater diversity of plant life, with species evolving unique adaptations to harness the dual sunlight, or develop different pigments to absorb light from different types of stars. These pigments could give plants a range of colors, creating vibrant and diverse ecosystems. The interplay of light and color would be a constant source of wonder and beauty. The behavior and navigation of animals would also be affected. Animals rely on the sun for cues about time and direction. With two suns, these cues would be more complex, requiring animals to develop new ways to navigate and survive. Migratory patterns, nocturnal habits, and even the way animals perceive their surroundings would likely be shaped by the presence of two suns. Birds might migrate at different times, nocturnal animals might adjust their activity periods, and all creatures would need to adapt to the unique light environment. The presence of two suns would create a world full of fascinating adaptations and endless possibilities. Section 6. Life finds a way? Maybe, maybe not. The question of whether life can exist on a planet with two suns is one that has intrigued scientists and enthusiasts alike for decades. It's a topic that delves deep into the realms of astrobiology and planetary science, pushing the boundaries of our understanding of life and its potential to thrive in the universe. The existence of life on a planet with two suns is a question that sparks endless fascination. Imagine standing on the surface of such a world with two suns casting their light and warmth. The dynamics of such a system would be vastly different from what we experience here on Earth. On one hand, the increased energy input from two stars could provide a wider habitable zone, the region around a star where temperatures are suitable for liquid water. This expanded habitable zone could mean more opportunities for life to develop and sustain itself. Liquid water is a crucial ingredient for life as we know it. The presence of two suns might create conditions where liquid water could exist in more regions of a planet, increasing the potential for life to arise. Water, being a universal solvent, plays a key role in the biochemical processes that are essential for life. This could potentially increase the chances for life to arise. The diversity of life forms that could emerge in such an environment is a tantalizing prospect. From microscopic organisms to complex multicellular life, the possibilities are endless. On the other hand, the complex gravitational dynamics and potentially extreme variations in light and temperature could pose significant challenges for life as we know it. The gravitational pull from two stars could create unstable orbits, leading to dramatic shifts in climate and environmental conditions. Whether life could evolve and thrive under such conditions remains an open question. Scientists continue to study extreme environments on Earth, such as deep-sea hydrothermal vents and acidic lakes, to gain insights into how life might adapt to harsh conditions. These studies help us understand the resilience and adaptability of life, offering clues about the potential for life on planets with two suns. The search for life beyond our solar system is one of the most exciting frontiers in science. As we discover more exoplanets and learn about their unique characteristics, we inch closer to answering the age-old question, are we alone in the universe? The possibility of life on a planet with two suns adds a fascinating dimension to this quest, reminding us that life, in all its forms, is incredibly resilient and adaptable. Section 7. Unraveling the mysteries of binary systems. Studying binary star systems is crucial for understanding the intricacies of star formation, stellar evolution, and the potential for life beyond Earth. By observing these systems, astronomers can measure the masses, temperatures, and compositions of stars. This data helps refine our models of stellar evolution and provides clues about the conditions under which stars form. Furthermore, understanding the gravitational interactions between stars in a binary system is essential for predicting the long-term stability of planetary orbits. This knowledge is crucial for identifying potentially habitable planets around other stars. Section 8. Binary stars, a window into alien worlds. Binary star systems offer a unique opportunity to study exoplanets, planets that orbit stars other than our sun. The presence of two stars can create gravitational perturbations that make it easier to detect exoplanets using the transit method, where astronomers look for dips in a star's light as a planet passes in front of it. Moreover, studying the atmospheres of exoplanets in binary systems can reveal clues about their composition and the potential for life. The presence of certain gases, such as oxygen or methane, could indicate biological activity. Section 9. Two Suns, Endless Possibilities. The possibility of Earth orbiting two suns is a captivating thought experiment that stretches our understanding of planetary systems and the conditions necessary for life. While the challenges of such an environment are significant, the potential rewards, from a scientific perspective, are immense. As we continue to explore the cosmos and unravel the mysteries of binary star systems, we gain a deeper appreciation for the diversity of worlds that may exist and the endless possibilities for life to arise in the vast expanse of the universe.